Hi everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and A-Level Further Mathematics Paper 2, which is the Further Pure Mathematics 2 for October-November 2021, and the code is 9231/22. Okay, so let's move on to question number 1. Question number 1 is given that y equals to sin x squared plus cos x squared. A. Use standard results from the formula list to find the Maclaurin series for y in terms of x up to and including the term in x degree 4. Okay, so from the formula list, the Maclaurin series for sin x equals to x plus x cubed over 3 factorial plus x degree 5 over 5 factorial and so on. Okay, and same goes to the cos x. In the formula list, the Maclaurin series equals to 1 plus x squared over 2 factorial plus x degree 4 over 4 factorial. So these are the Maclaurin series for sin x and cos x. Alright, so now your y equals to sin x squared plus cos x squared. So now we need to get the Maclaurin series for these two terms. Okay, so it's basically just replace the x in the original Maclaurin series by x squared. So all these x change to x squared. Alright, then we can find that we can get the Maclaurin series for the y easily. So now I will have to change the x by x squared. So first term is already x squared, and now Maclaurin series of y up to x degree 4 means that I will stop in the next step, right? So plus x squared cubed over 3 factorial. So we can ignore the degree 5 there, because you'll be getting the degree which is greater than x degree 4. So then from here, this will be the expressions for sin x squared. Then plus for the cos, I will replace it by 1 plus, replace the x by x squared, then square outside over 2 factorial. So if you are aware that this is already x degree 4, so I can ignore the next term. Alright, so from here, when you simplify, basically we are just referring to the first term in the first bracket and then these two terms in the second bracket. Alright, so when you simplify all these three terms, it will be 1 plus x squared plus x degree 4 over 2. Okay, this will be the Maclaurin series of y. Now for B, deduce the value of the fourth derivative when x goes to 0. So now I will get this differentiation, okay, this derivative based on the Maclaurin series that we have just formed. So now y equals to 1 plus x squared plus x degree 4 over 2. So now dy dx, differentiate 1 to get 0, x squared becomes 2x, then x degree 4 over 2 becomes 4x cubed over 2. Okay, and this is same as 2x plus 2x cubed. So now my second derivative of y with respect to x is going to be differentiate 2x is 2, differentiate 2x cubed, it will be 6x squared. Okay, and now we have to continue. So the third derivative of y with respect to x, differentiate 2 will be 0, differentiate 6x squared, it will be 12x. And lastly, the fourth derivative. So the fourth derivative is 12. So it means that now when x equals to 0, so even though you are given the x value, but then from the fourth derivative, it does not have x. So we will just always write down the constant. So the answer is 12. Okay, now C, use your answer in part A to find the approximation to this integration, giving your answer as a rational fraction in its lowest terms. So now integrate 0 to half y dx. It will be integration of 0 to half. My y will be the answer from A. So I will write 1 plus x squared plus x degree 4 over 2 dx. Okay, So now when we integrate 1, you get x. Integrate x squared, it will be x cubed over 3. Integration of x degree 4 over 2 is basically x degree 5 over 5. The 5 and the 2 at the denominator becomes 10. So here 0 to half. Okay, so now just need to replace the x value by half first. So I will get half plus half cube over 3 plus half degree 5 over 10. Then minus, where x equals to 0, everything is 0. So from here I will get half plus this 1 over 2 cube is 1 over 8. So divided by 3, it will be 1 over 24. Okay, 1 over 2 degree 5 is 1 over 32. Then you divide by 10, it will be 1 over 320. So when you add up these three values, you will be getting 523 over 960. Okay, so this is the lowest, this is a simplified rational function, rational fraction. Okay. Now, for question number 2, find the solution of the differential equation for which y equals to 1 where x equals to 1. Give your answer in the form of y equals to fx. So now, our differential equation is dy dx plus 4x cubed y over x degree 4 plus 5 equals to 6x. Okay, so for this question, obviously we cannot solve using separable variables. Okay, therefore the only method is by integrating factor. So I will let this be the first equation. So now my integrating factor, which is the I, right, or probably I rewrite this first, because the integrating factor you must get plus dy dx plus y of the function. So now I rearrange, so dy dx plus y, so that my function is 4x cubed over x degree 4 plus 5. That equals to 6x. This is my first equation. So now my I, integrating factor, I is exponential. Integration of 4x cubed over x degree 4 plus 5 dx. So from here, right, I need to apply the ln formula. So integrate f prime x over fx dx is ln fx plus c. So when you differentiate x degree 4 plus 5, I will be getting 4x cubed. That means the numerator is the differentiation of the denominator, which is exactly same as this form. Or in other words, I will be getting ln of the denominator, x degree 4 plus 5. Okay, then from here, the e and ln can be cancelled off because we have another formula. E ln a is a. Therefore, my integrating factor is only x degree 4 plus 5. So after you have found the integrating factor, multiply integrating factor into the first equation. So by default, the left hand side will be always d over dx yi. Okay, so I will write d over dx yi. Then for the right hand side, it will be 6x multiplied with x degree 4 plus 5. Okay, so from here, I will just do the expansion. It will be 6x degree 5 plus 30x. So differentiate left side to get right side means that left hand side is basically integration of right hand side. So now when I integrate 6x degree 5, it will be 6x degree 6 over 6, which means, right, later will be simplified into x degree 6. This is 30x squared over 2. And then plus c. So now I will simplify it into x degree 6 plus 15x squared plus c. Okay, now to get the c, we need to replace the x and y values. So the x is 1, y is 1. Therefore, for the left hand side, I will get 1 bracket 1 degree 4 plus 5, means that this is 6. Okay, for the right hand side, whenever you see the x with any degree, it will be always 1. So 1 plus 15 plus c. That means 6 is 16 plus c. That means the c is basically negative 10. Okay, so now I rewrite my solution. Then now the question says you need to get the y as a subject. Okay, y equals to fx. So I will just move down this x degree 4 plus 5 to the right side. Then you will be getting the solution. Okay, so that's all for this question. For question 3, okay, the diagram shows the curve with equation y equals to 1 minus x squared for x between 0 and 1. Okay, so this is y equals to 1 minus x squared. Now, together with the sets of n rectangles with the width of 1 over n. Here is 1 over n. Okay, now A, by considering the sum of the areas of the rectangles, show that the integration is less than this expression. So now, for your information, when you look at the rectangle here, so we know that area of rectangle is the base times height. Alright, so now all the base will be 1 over n, because it's mentioned the width is 1 over n here, and there are n rectangles. So now, for the first rectangle, the height here is referring to the first point, I mean the first ordinate of the rectangle. So which means you replace this x by 0, therefore I get 1. Okay, and then here, for the second rectangle, I'm referring to the first ordinate of the second rectangle, which means it's 1 over n. So I will say that this height, right? So this height is basically 1 minus 1 over n, which is my x squared. Okay, and then same goes to the last one. The last one here, it will be 1 minus, because we are referring to this ordinate. So this is my x now, n minus 1 over n squared. Okay, so this is how we get the how I get the height of the rectangles. So therefore now I will start with considering sum of the areas of rectangles. So now, sum of the areas of rectangles it is always the base, okay, 1 over n. Then now I just need to consider the heights for all the rectangles. So the height for the first rectangle is 1. And then for the second rectangle, okay, so the height is 1 minus square of 1 minus n. So 1 minus square of 1 minus n. Or square of 1 minus n, I will just write, okay, I will just write like this. And then plus, the next rectangle is going to be will be this x, right? So I just show you some values. So 1 minus 2 over n squared until the last rectangle, the height is this. So 1 minus n minus 1 over n squared. Right? So now from here, okay, we know that there are n rectangles in total. Okay, so which means you are adding this for n times. This first time, second time, third time, until n times. So, on other words, the 1 here already added n times. Okay, so I will say that this is basically 1 over n bracket n times 1. Okay, and at the same time, right, I need to consider all the remaining terms, which means here. Because I have considered all the 1 there. Right, so from all this highlighted, I mean the terms with which highlighted by the red color here, that means it will be all negative. Okay, and at the same time, the denominator always n squared. Right, so means that I will factorize that later on. So now, from here, I will take out the minus first. Then I show you clearly that it will be 1 over n squared plus the squared I bring in to the numerator and denominator for the second term here. This becomes 2 squared over n squared. Okay, plus until the last term n minus 1 squared over n squared. Alright, so then it shows clearly that the denominator, right, so the first term is n. So for the bracket, I can factorize the denominators. So it will be negative 1 over n squared. Then it will be just left 1 squared plus 2 squared plus until n minus 1 squared. Okay, so now from here, the 1 squared plus 2 squared plus until n minus 1 squared, this is basically summation r from 1 to n minus 1. Okay, whereby you need to summation r squared, the r from 1 to n minus 1. That is the, all these are the terms of the, in the bracket. Okay, when you consider all this, it will be same as the summation. So now from formula list, right? So from formula list, then summation r squared, r from 1 to n, it will be 1 over 6n, n plus 1 times 2n plus 1. Okay, but then when you refer to, when you compare to this expression now, the r start from 1 and it is r squared, but then our last r is not n, it's n minus 1. That means now I need to change the all the n by n minus 1 in the formula. Okay, then now here I will be getting 1 over n, then n minus 1 over n squared. So for this sum, I will refer to this formula, summation n r squared formula, and at the same time I change the n to n minus 1. That means you'll be getting 1 over 6, then the n change to n minus 1, right? So for the second term, it will be n minus 1 plus 1. Then after that, I will get 2 brackets n minus 1 plus 1. Okay, so this is how I get it. You just replace the n in the formula by n minus 1. And now I need to simplify it. So here, at last, you will get 1 over n times n minus, okay, 1 over, this is 6n squared. Alright, simplify all the brackets first. So simplify all this first. So here I will be getting n minus 1. Then the second bracket, n minus 1 plus 1 is basically just n. Now, the last bracket, when you do expansion, this is 2n minus 2 plus 1. So it becomes 2n minus 1. Okay, now before I proceed, the n and n squared, the n squared can be simplified into just n. And then at the same time, I factorize the 6n. Alright, so now here, look at the answer. We need 6n squared. So I will factorize 6n from the denominator and combine with the n outside here, it becomes 1 over 6n squared. So when I factorize 6n from the first term, which is an n, I will get 6n squared. Okay, because I factorize the 6n, so it means that this n need to be multiplied by 6n. Therefore, you get 6n squared. And then minus, alright, then here left these two terms, I will just do the expansion. So the n multiplied by 2n minus 1, you'll be getting 2n squared minus n. And then this minus 1 you times in, it will be minus 2n plus 1. Okay, so from here, I will get 1 over 6n squared. Then open the brackets, it will be 6n squared minus 2n squared times in the minus, right, bring in the minus. Then here you'll be getting plus n, then plus 2n, then after that minus 1. Alright, so at last you will be getting 1 over 6n squared. So 6n squared minus 2n squared will be 4n squared. N plus 2n is plus 3n, then minus 1. So now let's check. It is exactly the same as here already, right? So I just need to combine them. So it means that now here I'm getting 4n squared plus 3n minus 1 over 6n squared. This is the expression for the sum of all the areas of the rectangles. Okay, now we need to show this. So this integration is basically the area under the curve. Alright, so obviously when you consider this, alright, these rectangles, so rectangles will have more values. I mean the areas of the rectangles, the total of the areas of rectangles will be greater than the area under the curve, because your area under the curve is just this part. So these are the excessive parts from the area of the rectangle. Okay, so from here I will just write down area under the curve equals to integration of 1 minus x squared dx from 0 to 1. Okay, therefore integration is less than 4n squared plus 3n minus 1 over 6n squared. Okay, so that's the solution of this question. Okay, now B, use a similar method to find, in terms of n, a lower bound for the integration. Alright, so lower bound means we no longer refer to this rectangle, but now I will just use back the same diagram. Okay, your rectangle is to get lower bound, right? We no longer refer to the first ordinate, right? But we will be referring to the second ordinates right now. So means that your rectangle, it will be this. This is our first rectangle. Okay, this is our second rectangle. So it means that for each rectangle, we are referring to second ordinate. Just now we refer to the first ordinate. So which means the first height becomes 1 minus 1 over n squared. The second height, it will be 1 minus 2 over n squared. So for the last one, since we are referring to the second ordinates right now, so which means for here, for the last one, so or probably I can just add one more here. Right, so for this rectangle, I'm going to refer to n minus 1 over n. And then now for the last one, when it is 1, there's no rectangle because we have to refer to 1 here. Alright, basically, we are getting n minus 1 rectangle because we are losing 1 rectangle here. Alright, so please take note on this. So here will be n minus 1 rectangles. Right, so now use the same concept. My lower bound will be one over n. Okay, still 1 over n because the width remains. Then it's just that now my first term, my first height is 1 minus 1 over n squared. Second height is 1 minus 2 over n squared. Until the last one is 1 minus n minus 1 over n squared. Okay, so I will write down all this. So here is going to be 1 minus 1 over n squared. This is my first height. And then my second height is plus 1 minus 2 over n. Okay, I better square outside. Then this is square. Okay, plus, then here 1 minus n minus 1 over n squared. Okay, then here is going to be 1 over n. Now for all the 1 here, because it's plus, so I know that there are n minus 1 rectangles right now. Therefore, when you add it for n minus 1 times, I'll get n minus 1 times 1. Okay, then for the rest, since the minus are in common, so I will just take out the minus. So here is going to be minus. Then after that, 1 over n square plus 2 square over n square plus until n minus 1 square over n square. Okay, similar to just now, we need to factorize the denominator. So I will factorize n squared. Therefore, you'll be getting 1 square plus 2 square plus until n minus 1 squared. Okay, and use the same formula. This is basically 1 over n times n minus 1 minus 1 over n squared. This summation is summation r squared, r from 1 to n minus 1, which means it's exactly the same expression as just now. Okay, which is here. Exactly the same. So since it's exactly the same, then I will just copy the answer from this part. Okay. Or probably you can just copy this 1 over 6 or this. Alright. So I will write 1 over 6, then n minus 1, n to n minus 1. N minus 1, n to n minus 1. Okay. N minus 1, n to n minus 1. Okay. And now the n can be cancelled off. Okay, which means it is similar to previous, right? Okay, so from here, I will just simplify, right? So from here, I will get 1 over n, and this 6n will be taken out and combine with this. So 1 over 6n. Then now I times 6n to n minus 1. Then here minus. Then here for the n minus 1 times 2n minus 1, then you can just copy the solution here. See? N minus 1 times 2n minus 1. Then I'm getting this, which is 2n squared minus 3n plus 1. So I will just write 2n squared minus 3n plus 1. Okay, then here 1 over 6n. Then now for the first term, you need to just do expansion. So here is going to be 6n squared minus 6n. And then open the brackets, minus 2n squared plus 3n minus 1. So then you will get 1 over 6n. 6n squared minus 2n squared, it will be 4n squared. Right? Minus 6n plus 3n, it will be minus 3n. Then minus 1. So from here, I will get 4n squared minus 3n minus 1 over 6n. So that's the lower bound of this question. Alright, so now for question 4a, write down all the roots of the equation x degree 5 minus 1 is 0. So now x degree 5 equals to 1. Right, I move the minus 1 to the right side. That means this is same as cos. Right, we know that the r is going to be 1. Okay, and then since this is 1 here, that means the angle is 0. Alright, this is your complex number. I mean, this is your root. So if I express in the polar form, it will be cos 0 plus I sine 0. But then since it is degree 5, we need to generate 5 roots. So you have to plus 2p pi. Otherwise, you can't get 5 roots. Okay, whereby the p equals to 0, 1, 2, 3, and 4. So these are the 5 different values of p to get 5 roots. So now from here, my x, according to the de Moivre's theorem, this 5 will be moved down. Okay, so it will be cos 2p pi over 5. Then plus I sine 2p pi over 5. This is using de Moivre's theorem. Because when you move the 5 to right side, it will be x degree 5 equals to 1, which means x is 1 to the power 1 over 5. Okay, so because of the 1 over 5 here, then according to the de Moivre's theorem, you just bring it into the theta, to the angle. So I'm getting this now. So now just need to replace the p by 0 until 4, and you'll be getting the answers. So now my x will be, cos 0 plus I sine 0, then cos 2 over 5 pi plus I sine 2 over 5 pi. So we need to list out 5 roots. So when p equals to 2, I will get 4 over 5 pi plus I sine 4 over 5 pi. So the next one is going to be 6, comma. Okay, then the last one is cos 8 over 5 pi plus I sine 8 over 5 pi. And now we need to write down all these calculations. So it will be equals to 1. For the first one is 1. The second one is 0.309 plus 0.951i. And then negative 0.809 plus 0.588i. And then negative 0.809 minus 0.588i. And the last one is going to be 0.309 minus 0.5951i. So you should get 5 values, 1, 2, 3, 4, 5. Okay, so these are the 5 roots for the A. Okay, now B. Use de Moivre's theorem to show cos 4 theta equals to 8 cos degree 4 theta minus 8 cos squared theta plus 1. So now cos 4 theta plus I sine 4 theta is basically cos theta plus I sine theta to the power 4. Okay, then from here, I will change the cos theta to C, the sine theta to S. So now my C is cos theta, my S is sine theta. And now to do this expansion, we need to refer to the binomial expansion. So binomial expansion is A plus B to the power n equals to A degree n plus nc1 an minus 1, b degree 1 plus nc2 a degree n minus 2 b squared plus until b degree n. Otherwise, you can just use the Pascal triangle. So now here I'm using the binomial expansion. So this is going to be c degree 4 plus 4c1 c degree 3 is degree 1 plus 4c2 c squared is square plus 4c3 c degree 1 is degree 3 and lastly is degree 4. Okay, so now I will simplify all the terms. So here is going to be c4. Now 4c1 is 4. Okay, 4c cubed si. Then plus 4c2 is 6. So 6c squared s squared I squared plus the next one is 4. 4cs cubed I cubed plus s degree 4 I degree 4. Now to simplify the I, we know that I squared is minus 1. So I degree 3 is I squared times I, which means it is minus 1 times I. So minus I. And same goes to I degree 4, it will be I squared squared. Square of I squared. That means it's square of minus 1, then you'll be getting 1. Okay, so I will change this to minus 1. This is minus I, and this is positive 1. Then here you will be getting C4 plus 4c cubed as I minus 6c squared as square minus 4c as cubed I, then plus s degree 4. Okay, so now for the cos 4 theta plus I sin 4 theta, you are getting 5 terms. But now you need to prove cos 4 theta only. So I will say cos 4 theta is basically real part of the right hand side. RE means real part. Okay, so for real parts means we just take the terms without I. So that is cos c degree 4 minus 6c squared s squared plus s degree 4. Okay, then I convert the c to be cos. So here cos degree 4 theta minus 6 cos squared theta sine squared theta plus sine degree 4 theta. Okay, so now let's look at the question. You need to prove all in terms of cos. See here, cos. So there's no sine, right? Therefore, I need to convert my sine into cos. So our formula is sine squared or cos squared theta plus sine squared theta is 1. Therefore, sine squared theta is 1 minus cos squared theta. Okay, so now here I will change the second term, the sine squared theta into 1 minus cos squared theta. And then for the sine degree 4 is basically square of sine squared. So I will write 1 minus cos squared theta. This is my sine squared, then I square outside. So then from here, you will get cos degree 4 theta minus, and then for the second term, just do expansion. Group this as one term and expand. So it will be 6 cos squared theta. Now, for the second term, be careful, there's a minus. So this minus and minus becomes plus. So here we will be getting plus 6 cos degree 4 theta. And lastly, square of 1 minus cos squared, use the quadratic expansion, so which is square of a plus b. Then I will get a squared plus 2ab plus b squared. Then you will be getting 1 minus 2 cos squared theta plus cos degree 4 theta. Okay, so now simplify all the terms. So the first term plus last term and also this middle term, it will be 8 cos degree 4 theta. Okay, and then for the cos squared plus these two together, it will be minus 8 cos squared. Lastly, plus 1. Okay, so we have found the form, therefore shown. So this is the solution of part B. Okay, now part C. Use the results of parts A and B to express each real root of the equation in the form of cos k pi, where k is a rational number. Okay, now since it's given a hint here, use the results from parts A and B. Okay, so let's go back to the parts A. Parts A, we have found the roots for x degree 5 minus 1. Okay, equals to 0. And then parts B, cos 4 theta equals to these expressions. Right, now what to do is from here, since the x degree 5 minus 1 equals to 0, already found the solution, means that now I have to factorize this. Okay, so I will factorize it by using the long division or polynomial division. So 8x degree 9. Supposedly after degree 9 it is degree 8, but there's no degree 8. It jumps to degree 7. So I will write plus 0x degree 8 minus 8x degree 7. And there's no degree 6. So 0x degree 6 plus x degree 5 minus 8x degree 4 plus 0x cubed plus 8x squared plus 0x minus 1. Okay, then divided by x degree 5 minus 1. Because we have solved this equation. Now, to get 8x degree 9 from x degree 5, which means we need to multiply x degree 5 by 8x degree 4. Okay, so here, 8x degree 4. Multiply with 8x degree 5, you'll be getting 8x degree 9. So 8x degree 4 multiplied by minus 1 is minus 8x degree 4. Then you minus. So the 0x degree 8 becomes 0. Bring down the negative 8x degree 7. Bring down the plus x degree 5. Okay, and then I will bring down one term. I bring down 8x squared. So now in order to get negative 8x degree 7 from x degree 5, so you need to multiply the x degree 5 by negative 8x squared. Alright, then you will be getting negative 8x degree 7, then plus 8x squared. Then now again I minus. So bring down the x degree 5. So 8x squared minus x squared no more. Then bring down the minus 1. Okay, so obviously now we need to multiply by plus 1. Okay, so which means my 8x degree 9 minus 8x degree 7 plus x degree 5 minus 8x 4 plus 8x squared minus 1 equals to 0. This can be divided by x degree 5 minus 1. And the quotient is 8x degree 4. This is your quotient. Minus 8x squared plus 1 equals to 0. Okay, so when we solve these equations means that x degree 5 minus 1 equals to 0, or 8x degree 4 minus 8x squared plus 1 equals to 0. So for the first one, alright, we already solved just now. So here, x degree 5 equals to 1, x will be 1. Alright, so because the question says real root, so from the first part, A, go back to A, we are getting 4 complex, 1, 2, 3, 4 complex roots, only 1 real root. And this one comes from cos 0. Okay, so now I will just write down real root, and it must be in cos k pi form. Therefore, here is going to be x equals to cos 0. That is my first value. Now, for the x, it's x degree 4 minus 8x squared plus 1 equals to 0. And now you refer to the part B. So it is the same as 8 cos degree 4 minus 8 cos squared plus 1. Whereby your x is the cos theta right now. Okay, so now from here, I'll let x equals to cos theta. That means this left hand side is basically same as cos 4 theta because they are the same. Right? So when you are solving the quadratic equation here, that means you are solving cos 4 theta equals to 0. So when cos 4 theta equals to 0, my 4 theta, right, is going to be, when you refer to the cos graph, okay, let's say I refer to cos graph. Alright, so it will be, this is cos 1 theta. Okay, cos 1 theta. So when it is 0, you can just say it will be here, these 2 points, right? Here is going to be 2 pi. My graph is not very accurate. Right, here is 2 pi. This is pi. Half pi. Sorry. And this is 3 over 2 pi. Okay, so from here I will say that now when you refer to the, let's say I draw a bigger one, then you can see clearly. Here is 2 pi, this is pi, and then this is half pi. This is 3 over 2 pi. Okay, so I will say that this cos for data is 0, means that your cos, your for data is going to be, you see here, over 2 over 2. So I will write half. Now, for the numerator, it is 1, 3, then the next one is going to be 5, all the odd numbers. So we know that odd numbers will be even number plus 1. Okay, odd equals to even plus 1 or even minus 1. So if even means that always 2k. Okay, here I use k. Then it can be either 2k plus 1 or 2k minus 1. So now I let my k be 0. So if my k be 0, okay, which means the original data, then I have to choose 2k plus 1, because when 2 times 0 is 0, 0 plus 1, I get 1, which is 1 pi over 2. Okay, but if you choose this, your k cannot be 0. Your k must be 1. So now, for easier calculation, I'm using k equals to 0 and 2k plus 1 to show this general results. So here I will get 2k plus 1, whereby the k equals to 0, 1, 2, 3. There are just 4k values because here 4 data. So therefore, my data is going to be 1 over 8 of 2k plus 1. Okay, I miss out the pi, because you have 1 pi over 2, 1 pi over 2, 3 pi over 2, and so on. So here you have another pi. Alright, so from here, now, final answer is cos k pi. Okay, so again, here the k equals to 0, 1, 2, 3. Which means now, my x is going to be cos 0, then cos pi over 8. Because when my k equals to 0, I get 1 pi over 8. Then when my k equals to 1, I get 2 times 1 is 2. 2 plus 1, 3. So I get 3 over 8 pi. Then the next one is going to be 5 over 8. It will be always odd number in the numerator. Then lastly, cos 7 over 8 pi. Okay, so this will be the solution of this question. Right? So now for next question, number 5. The curve C has parametric equations x and y in terms of t, whereby the t is defined from 1 to 2. A is given that a is 2 over 3, b is negative half. Show these expressions. Right? Show this expression and find the exact length of C. So now, when a equals to 2 over 3, b equals to negative half, then I have to rewrite my x and y. So now my x is 3t plus 2t degree negative 1, then plus 2 over 3 t cubed. Okay, then my y is going to be 4t plus 3 over 2 t degree minus 1, then minus half t cubed. Okay, so now firstly I get the dx dt. So now my dx dt, differentiate x, it will be 3. Then bring down the minus 1, it will be negative 2t power negative 2. Bring down the 3, so 3 and 1/3, it will be cancelled off. Then I get 2t degree 2. This is my dx dt. I get the squared first. So now my dx dt squared. So since you have three terms here, it's better to list down, okay? Two brackets. I will not apply the quadratic expansion because there are three terms here. So I will just list out the terms and do the expansion one by one. So now firstly, multiply the second bracket with 3. Okay, so all the terms multiplied by 3, you will get 9 minus 6t power negative 2 plus 6t squared. And then the next is multiply the second brackets by minus 2t negative 2. So here I will get negative 6t power negative 2. So minus minus is a plus 4t. Degree minus 2 times degree negative 2 means that you plus. So degree negative 4. Then lastly, negative 2t power negative 2 multiply with 2t power 2. It will be just minus 4. Because t power negative 2 times t squared, it will be t degrees 0. Okay. Lastly, multiply 2t squared by the whole bracket. So you will get plus 6t squared minus 4 because t squared and t degree negative 2 will be cancelled off. Then here you will get plus 4t degree 4. Okay, now simplify first. So from here, right, the first term is 4t degree 4. And then followed by 4t degree negative 4. Okay, then t squared. 6t squared, 6t squared. So 12t squared. After that, negative 6t, negative 2, and then negative 6t, negative 2. So it means that negative 12. T power negative 2. Okay, lastly, left the constants. So the constants, 9 minus 4, which is, okay, another minus 4 here. Alright, 9 minus 4, so it's 1. Okay, so this is the expression for square of dx dt. Now I need to get dy dt. So my dy dt, differentiate 4t is 4. Bring down the minus, so you get negative 3 over 2 t power negative 1 and negative 2 because you differentiate. Okay, this 3, move it down, negative 3 over 2 t squared. And now here, I will square it. So here is going to be 4 minus 3 over 2 times t power negative 2 minus 3 over 2 t squared, then multiply by itself. So again, use the same concept. The second bracket multiply by 4 first. You will get 16. Then 4 times 3 over 2 is basically 6. So minus 6 t power negative 2. Okay, let me check the differentiation. Okay, now for information, I found a mistake here. You see, this is minus, but I wrote plus. Alright, so this one should be minus. So here minus. So when you differentiate, bring down the minus 1, it will be plus. Alright, so here is plus. This is plus. So here is plus. Okay, then now when you do expansion, 4 times negative 3 over 2 t squared, it will be minus 6 t squared. So next, expand the brackets by 3 over 2 t power negative 2. Then here you will be getting plus 6 t power negative 2. Then plus 9 over 4 t power negative 4. Okay, then 3 over 2 3 over 2 t power negative 2 multiplied with this term, it will be plus, not plus, minus. It will be minus 9 over 4. Okay, lastly, negative 3 over 2 t squared multiplied by the bracket. Okay, just do the expansion one by one. Then you get negative 6t squared minus 9 over 4 plus 9 over 4 t degree 4. And now again simplify. So you will be getting 9 over 4 t degree 4 plus 9 over 4 t degree negative 4. Then minus 12t squared plus 12t power negative 2 plus 23 over 2. Okay, so 23 over 2 is 16 minus 9 over 4 minus 9 over 4. So now we have found these two expressions, square of the dx dt and dy dt. Therefore now you need to get the sum and show this form. Okay, so now I add up these two expressions. So when I add up, I will just copy all these terms, right? So I get all these terms from the dx dt squared. And then now I plus with the dy dt squared. Now when you simplify, you will be getting 25 over 4 t degree 4 plus 25 over 4 t degree negative 4 plus 25 over 2. Okay, then now when you look at the answer here, we need to get 25 over 4 times the square of this. Alright, so now I will factorize 25 over 4 first. Then I will get t degree 4, then plus t degree negative 4 plus 2. Now I will rearrange. This is basically t degree 4 plus 2 plus t to the power of negative 4. Okay, but then when you look at the answer here, it is square of t squared plus t power negative 2. So you just need to take out the square. Alright, so this is the solution. Now, don't forget to find the exact value, exact length of C. So now, length of C, it is integrate. So look at the question here, the t from 1 to 2. Okay, so you have to integrate from 1 to 2, square root of dx over dt squared plus dy over dt squared dt. So this is your formula. Okay, so here I will replace it by this form. So 1 to 2, 25 over 4 t squared plus t degree negative 2 squared. Don't forget the square root. So now, square root of 25 over 4 is basically 5 over 2. Okay, so the square and square root can be cancelled off. Right? Therefore, I will get t squared plus t power negative 2. So to integrate this, right, it is a basic integration. So I will continue here. So this is equals to 5 over 2. Then from here, right? Then integrate t squared, it will be t cubed over 3 plus t power negative 2 is t power negative 1 over negative 1. Then limits from 1 to 2. So here, now just need to replace the t by 2 first. So I will get 8 over 3 plus, okay, this plus and minus is basically minus. So here I will write minus 1 over 2 because t power negative 1 over negative 1 is negative 1 over t. Then minus when the t is 1. So 1 cubed over 3 is 1 over 3. Then minus 1 over 1 is 1. Okay, so from here at last you will get 85 over 12. So that is the arc length of the C. Okay, now B, it is given that instead A equals to A equals to B equals to 0. Find the value of d squared y over dx squared when t equals to 1. So now, when the A and B equals to 0, then now you have to rewrite your dy, your x and y. Okay, so now my x is 3t plus 2t power negative 1. So x equals to 3t plus 2t power negative 1. That is my x. Then the y is 4t minus 3 over 2t power negative 1 because the b equals to 0. So the y is 4t minus 3 over 2 t power negative 1. Okay, so from here, just differentiate dx dt. It will be 3 minus 2t power negative 2. And then dy dt, it is 4 plus 3 over 2t power negative 2. Now, since we need to get the dy dx first, that means that is going to be the chain rule. So I better simplify my t power negative 2. So I change to 3 minus 2 over t squared. Okay, and this is 4 plus 3 over 2t squared. Then I get the same denominator. So here is going to be 3t squared minus 2. And then for the dy dt, it's going to be 8t squared plus 3. So now, my dy dx is dy over dt times dt over dx. This is a chain rule. So which is 8t squared plus 3 over 2t squared multiplied with 3t squared minus 2 over t squared. Okay, so now here I will, okay, wait, times dt over dx, I mistake. For your information, dt over dx is 1 over dx over dt. Okay, so I take the inverse of this. So it means that I just swap the numerator and denominators. So here, I should get this term. And then now, the t squared will be cancelled off. Okay, and at last, you will get 8t squared plus 3 over 2 times 3t squared minus 2. This is your dy dx. But then now the question is asking for the second derivative. So now, I need to differentiate my dy dx with respect to t because my dy dx is in terms of t right now. So here, dy over dx. So when I differentiate this, obviously this is quotient rule. So I square the denominator. Okay, for your information, quotient rule is d over dx u over v. The formula is over v squared, vu prime minus uv prime. Okay, so now I square the denominator. I keep the denominator, which is my which is my v. Okay, after that I differentiate the numerator. So when I differentiate, I will get 16t minus Now keep the numerator, differentiate the denominator. So the denominator, when you differentiate, this is basically 6t squared. So the squared you bring down, it will be 6t squared becomes 12t. Okay, the last term is a constant, just ignore it. So this is your d over dt, dy over dx. No need to simplify because I need to get what is the value when t equals to 1. So I will write when t equals to 1, this is d over dt, dy over dx. So just replace the t by 1. I will get 2 bracket 3 minus 2 times 16 minus 8 plus 3 times 12 over 2 bracket 3 minus 2, then I square it. So this is going to be 2 times 1 times 16 minus 11 times 12 over 2 times 1, I squared it. Okay, then here is going to be negative 25. So now I need the dx dt. So now my dx dt equals to 3t squared minus 2 over t squared. So 3t squared minus 2 over t squared. Therefore, it is 1. Therefore, d squared y over dx squared is d over dt dy over dx times dt over dx. So now I just substitute all my values. Okay, so for the d over dt dy over dx, the value is negative 25. Then dx dt is 1. So I will just replace negative 25 and 1. Okay, this dx dt is 1 over 1, right? Therefore, I will be getting negative 25. So this is the value at t equals to 1. Okay, so that's all for this question. Now question 6. The matrix P is given by P equals to 166, 026, 003, 00, negative 3. Use the characteristic equation of P to find P inverse. Okay, so now for characteristic equation is always P minus lambda I, determinant of P minus lambda I equals to 0. So it means that for all the diagonals, you minus lambda. So I'll get 1 minus lambda, 0, 0, 6, 2 minus lambda, 0, 6, 6 minus 3 minus lambda. Okay, then from here, I will fix the first column because there are 2 zeros here, the sign is plus. Then now you consider the first row, right? So if we consider the first row, the cross out is 1 minus lambda. Therefore, I will write plus 1 minus lambda, determinant of the remaining terms. Then now it has been reduced to 2 by 2 determinant. Then you will get 2 minus lambda times minus 3 minus lambda, then minus 0. Then from here, right, because we need to get the equation of P, right, characteristic equation of P, therefore now here I have to do expansion. So 1 minus lambda, when you expand these two terms, you will be getting minus 6 minus 2 lambda plus 3 lambda plus lambda squared equals to 0. And then further expand it, right? So you will get minus 6 plus lambda. Okay, because here, how to get plus lambda? I simplify this. This is plus lambda, right? Then here, plus lambda squared, because you multiply by 1. Then after that, these three terms multiply with minus lambda. So you will be getting plus 6 lambda minus lambda square minus lambda cube equals to 0. And now the lambda squared will be cancelled off, right? And then rearrange and move all the terms to right side because my minus lambda cube is, my lambda cube is negative. So I want to make it to positive. I move all the terms to right side. So then you will get lambda cube minus 7 lambda plus 6 equals to 0. Okay, then from here, since you need to get the p, right, equation of p. So now the lambda cube will be changed to p cube. The 7 lambda will be changed to 7p. The 6 will be changed to 7i. So that it is a matrix. The I is the identity matrix. Now, we need to use that equation to find P inverse. So in order to get P inverse, just take the inverse, P inverse for both sides. So P inverse is P cube. This 0 is basically a 0 matrix, right? So 0 matrix. So minus 7P plus 6I equals to P inverse times 0 matrix. So here, when you do expansion, you will be getting P squared minus 7I, because P inverse times P is I. Then 6I times P inverse, it will be 6PI. Then the right hand side remains as 0. So from here, my 6P inverse equals to 7I minus P squared. And now the question asks for P inverse. Alright, so now I need to get what is my P squared first. So my P squared, I will just square this, right? So I multiply by itself. So it will be 166, 026, then 0, 0 minus 3. Multiply by itself. So when you multiply this, right, row times column, and then you plus together. So 1 times 1 plus 0 times 6 times 0 plus 6 times 0. Then you will be getting this whole matrix. So 1, then here is going to be 18, then 24, 0, 4 minus 6. So you just do the calculations, 0, 0, 9. Okay, that is our P squared. Now we need to get P inverse. So from here, P inverse is 1 over 6 of 7I minus P squared. Right, let's say, let this be the first equation. I will write from first. Then this is going to be 1 over 6 multiplied with 7I. So it will be 700, 070, 007. Identity matrix multiplied by 7 minus this matrix. Right, then here you will be getting 1 over 6 of matrix 6 minus 18 minus 24, 0, 3, 6, 0, 0, negative 2. So then when you simplify, it will be 1, negative 3, negative 4, 0, half 1, 0, 0, negative 1 over 3. So that is your P inverse. Okay. Now B, find matrix A such that P inverse AP equals to this. So now P inverse AP times another P inverse, it will be P of 400, 050, 006, and then P inverse. So for the left hand side, I'm getting the A already. Alright, so just replace your P by 166, 026, 00 minus 3, then multiply with 400, 050, 006, and the P inverse that we have just found. Okay, then now when you do expansion, I expand the first two matrices, you will be getting 4, 30, 36, 0, 10, 36, 0, 0 minus 18, then multiply with 1, 3 minus 4, 0, half 1, 0, 0, negative 1 over 3. So when you do expansion here, at last you will be getting 4, 3, 2, 0, 5, negative 2, 0, 0, 6. Okay, so that's the matrix A. Now, state the eigenvalues and corresponding eigenvectors of A cube. So now from parts B, we found the A. Okay, this A is basically P, D, P inverse. Right, so from parts B, A equals to P, D, P inverse. Right, that means the P is 166,026,0,0, negative 3. And then the D is 400,050,006. All this from previous questions. So from here, I need to get A cube. So now you cube it. It will be P, D cube, P inverse. Right. So now from here, my eigenvalues of A cube. So just cube all these eigenvalues. So it'll be 4 cube, 5 cube, 6 cube. So which means it will be 64, 125, and 216. Then the corresponding eigenvectors of A cube. So when 4, it will be 100. Okay, when 5, it will be 620. Refer to the columns. So these are the eigenvalues and eigenvectors. That's why the question says state. Alright. Now, question number 7. Given that y equals to x squared w and the form, okay, so now we need to integrate. Now we need to show this differentiation. So what we do is y equals to x squared w. Therefore, w is y over x squared because there's no more w. And then this is y x power negative 2. Now, your dw over dx. Right, I need to differentiate this. So use a product rule. Y negative 2 x negative 3 plus 1 over x squared dy dx. Okay, so I refer to this form for the differentiation of, second parts of the product rule. So here is going to be negative 2y over x cubed plus 1 over x squared dy over dx. Now, I have the d squared y over d squared w over dx squared. So now I have to differentiate. So from here, I will get negative 2y x power negative 3. Okay, then plus this is x power negative 2 dy over dx. So now I will differentiate. So d squared w over dx squared, again product rule, uv. Right, so you will you can just write okay, you can write this, keep differentiate, so minus 3x negative 4 plus keep the x power negative 3, differentiate minus 2y, it will be minus 2 dy dx, plus keep the x power negative 2, differentiate dy dx is d squared y over dx squared, then plus keep the dy dx and differentiate x power negative 2 is negative 2x negative 3. Okay, so from here, simplify, you will get 6y over x degree 4. The next one is negative. Okay, now when you check, the second and fourth term are the same. So I will combine both. So it will be minus 4 over x cubed dy over dx. Then last term, third term will be 1 over x squared d squared y over dx squared. Okay, so now substitute all this into here. Just replace. So now I will copy the equation first before I replace. So x squared d squared w over dx squared plus 4x bracket x plus 1 dw over dx plus 5x squared plus 8x plus 2, w equals to 5x squared plus 4x plus 2. Okay, so now replace the first and second derivative. So I'll get x squared 64 over x degree 4 minus 4 over x cubed dy dx plus 1 over x squared d squared y over dx squared. Okay, plus 4x bracket x plus 1 minus 2y over x cubed plus 1 over x squared dy dx. Okay, then copy the rest and change the w to y over x squared. Okay, so now simplify. So I will get, okay, wait, d squared y, okay, this is 6y, right? I overlook it and root 64. This is 6y. Okay, so when you do expansion, you will get 6y over x squared minus 4 over x dy dx plus d squared y over dx squared. Okay, then the next one is minus, because when you do expansion, the x and x cubed will be simplified. So get minus 8y x plus 1 over x squared plus 4 times x plus 1 over x dy over dx. Then plus 5y, here you do expansion. Okay, then plus 8y over x plus 2y over x squared when you do expansion. Then equals to 5x squared plus 4x plus 2. Okay, so now I will get d squared y over dx squared, which is this term. So for those with dy dx, these two terms, right? And yeah, for these two terms, you can factorize the plus dy dx. Then you will get negative 4 over x plus, okay, here just do expansion. So 4x over x plus 4 over x. Then plus the rest. So the rest of the terms, 6y over x squared minus 8y squared. This one you do expansion. So when you do expansion, you get 8yx over x squared. Okay, then minus 8y over x squared. Then here 5y. After that, 8y over x plus 2y over x squared. Then equals to 5x squared plus 4x plus 2. Okay, so from here, d squared y over dx squared. So now when you look at the bracket, these two terms will be 0. The x will be cancelled off, so I just get 4. Alright, so now for the next bracket, the x cancel off, so means that these two terms will be 0. Alright, then the rest of the three terms, when you simplify, here 6 plus 2, 8. 8 minus 8, it will be 0. That means only left 5y. Okay, so here I will get plus 5y equals to 5x squared plus 4x plus 2. Okay, so that is the expression that we have proven. right? So now next, find the general solution of for w in terms of x. So now we need to solve this differential equation. So now I have to solve this, right? D squared y over dx squared plus 4 dy over dx plus 5y equals to 5x squared plus 4x plus 2, whereby the y is x squared w. So now I will let right side be 0. So the auxiliary equation, then the A is 1, B is 4, C is 5. So the M is minus B plus minus square root of B squared minus 4AC over 2A. So you will get negative 4 plus minus square root negative 4 over 2, and then it will be minus 2 plus minus I. So my complementary function y is e negative 2x a cos x plus b sine x. So now for the left hand side, for the right hand side, so I will let y be px squared plus qx plus r. So now dy dx, it will be 2px plus q. D squared y over dx squared, it will be 2p. So I let all this be second equation, and this is my first equation. So now I substitute second into first. So I will get 2p plus 4 times 2px plus q plus 5 times px squared plus qx plus r equals to the quadratic function. Okay, so from here, I will simplify it. You will get 5p squared plus x of 8p plus 5q, then plus the constant, that equals to 5x squared plus 4x plus 2. Right, so now when I compare, so I will just do it here because of not enough space. So when I compare, my 5p equals to 5. Therefore, my p is 1. Then 8p plus 5q is 4. Okay, so 8 plus 5q is 4. Therefore, 5q is minus 4. Hence, your q is minus 4 over 5. Then lastly, 2p plus 4q plus 5r, which is a constant. So now you replace. P is 2. The q is minus 4 over 5 plus 5r equals to 2. Then from here, when you simplify, your 5r is 16 over 5. Hence, your r is 16 over 25. Okay, so my particular integral, my y is x squared minus 4 over 5x plus 16 over 25. So the general solution, y is CF plus PI. So therefore, you will get e negative 2x a cos x plus b sine x, then plus x squared minus 4 over 5x plus 16 over 25. But, okay, find the general solution for w in terms of x. So from here, change back. So it means that you get the y, right? So your y is x squared w. So just change the y by x squared w. And then get the w as the subject. So your w is e negative 2x over x squared a cos x plus b sine x. So plus all of this divided by x squared. So here I will get 1 minus 4 over 5x plus 16 over 25x squared. So that is your solution of W. Okay. Now, question 8. Starting from definitions of hyperbolic tangent and hyperbolic secant, in terms of exponential, prove that 1 minus tangent squared x equals to hyperbolic secant squared x. So now we know that hyperbolic tangent squared x is sine x over cos x. So this is half of ex minus e negative x over half of ex plus e negative x. Therefore, it is ex minus e negative x over ex plus e negative x. Okay, and then the hyperbolic secant x is 1 over cos x, means 1 over half of ex plus e negative x. So the 1 over half, it becomes 2. Right. Now I need to prove from the left hand side. So 1 minus hyperbolic tangent square x. So it will be 1 minus square of this term. So now I will do expansion for the quadratic. Then you will get e2x plus 2 plus e negative 2x. So here e2x minus 2 plus e negative 2x. Okay, and I get the same denominator. Then here you get e2x, so multiply by 1. Just rewrite the denominator. Bring in the minus to these 3 terms. Then here, when you simplify, right, so these 2 terms cancel off, then you will get 4. So the other 2 terms also cancel off. Right, these 2 terms also cancel off. Numerator only left 4. Then denominator, instead of these 3 terms, I will change back to square. It will be ex plus e minus x squared. This is same as secant squared x. Alright, just square this. Alright, done for this proving. Now B, use the substitution. Use the substitution u equals to hyperbolic tangent x, or otherwise find this integration. So now, integrate hyperbolic secant square x, tangent square x dx, whereby the u is hyperbolic tangent x. So when we get the du dx, this is hyperbolic secant square x. So it means that your du is hyperbolic secant square x dx. So now from the question, I will combine these two to be du. So which means it will be integrate u square du. Okay, so when you integrate u square du is u cubed over 3 plus c. Then change back your u. So your u is tangent cube x over 3 plus c. So this is your integration for part B. Now C is given that In is this expression. Show that n at least 2, you get this you may use this result. Okay, so now what to do is your IN is integrate 0 to ln 3 hyperbolic second and x tangent squared x dx. So this can be changed into this form. Because I want to use previous result, so I need to introduce a hyperbolic second squared x. Alright, then from here I will use the by parts formula. So when u equals to second n minus 2 x, my du over dx is n minus 2 second n minus 3x. Differentiate second is negative second x tangent x. Probably I just write it here because of not enough space. So this is same as negative n minus 2 hyperbolic tangent x second n minus 2x. Okay, then dv over dx is second square x tangent square x. So from the previous, we have found this tangent cube x over 3. Okay, so now my IN, use the integration by parts, you will get uv minus integrate v du. Okay, so from here when you simplify, you will get 1 over 3. Okay, replace the x by ln 3, right? So at the same time, I replace the tangent and second by the exponential form. So I will get 2 over e ln 3 plus e negative ln 3 to the power of n minus 2. Okay, then exponential ln 3 minus e negative ln 3. This is for the tangent, hyperbolic tangent x. Then here e ln 3 plus e negative ln 3. Because your answer here without the will be just all numbers. So that's why we have to use the definition. Okay, then minus when the x is 0. Okay, then plus, so simplify this, it will be n minus 2 over 3. Integrate from 0 to ln 3 hyperbolic second n minus 2 x tangent power 4x dx. So now here simplify the terms first. I will get 2 over 3 plus 1 over 3 to the power of n minus 2. 3 minus 1 over 3 over 3 plus 1 over 3. Okay, because e ln can be cancelled off. But then when you simplify, e negative ln 3 is basically e ln 3 power negative 1, which is 3 power negative 1. And I get 1 over 3. Okay, this is how I get 1 over 3 here. Then this is power 3 minus 2 over 2 power n minus 2, and this is 0. Okay, 1 minus 1 is 0. Then plus, close bracket. Okay, then plus n minus 2 over 3 integrate 0 to ln 3. Okay, here the tangent power 4 I will change to identity. 1 minus tangent square x is secant square x. So tangent square x is going to be 1 minus hyperbolic secant square x. Alright, so here I will get secant n minus 2x tangent square x multiplied with 1 minus secant square x. Then here you will get 1 over 3. So when you simplify, the first term is 3 over 5 power n minus 2. Then the second term is going to be 4 over 5 to the power of 3, close bracket, plus n minus 2 over 3 integrate 0 to ln 2, though here you multiply by 1. Okay, so we multiply by 1, just rewrite. And then now you do expansion, this multiply with hyperbolic secant square x. So here I will write another bracket, right, because I've not enough space. Then here minus integrate 0 to ln 2 hyperbolic secant degree n x dx, because the n minus 2 and square and the 2 becomes n. Then there's no dx yet, you still have the tangent at the back. So hyperbolic tangent square x dx, then close bracket. Okay, so now from here, this 3, because left hand side equals to in. See here, left hand side equals to in. So I will write in here, right? Because now I notice that both also over 3. So this 3 I move up, becomes 3 in equals to rearrange the terms, then plus this one left n minus 2, and this whole integration is the in minus 2 minus, right, don't forget this n minus 2 multiply to this as well, so I will write n minus 2, then this whole integration is the in. So now the in will move to the left hand side, so the in I will write 3 plus n minus 2, because this is minus, so when you move there, this is plus, then just copy back the n minus 2. Then I will write it is 4 over 5 cubed 3 over 5 to the power of n minus 2 plus n minus 2 in minus 2. So now I simplify. This is basically 3 minus 2 is 1. So it is the same as n plus 1 in. Okay, so we have proven the formula, right? So you have to apply the integration by parts. So D, find the value of I4. So refer to the previous form. Now m plus 1 in is 4 over 5 cubed 3 over 5 n minus 2 plus n minus 2 I n minus 2. So when I4 means my n is 4. So when my n is 4, I get 5I4 equals to 4 over 5 cubed. 3 over 5, 4 minus 2 is 2, plus 4 minus 2 is 2, then 4 minus 2 again, it will be I2. So now I need n equals to 2. So left hand side 3I2, right hand side is 4 over 5 cubed times 3 over 5 squared, not squared. Okay, because now your n is 2, so 2 minus 2 is power 0. Then plus, now n minus 2 is 0, so everything is 0. Okay, which means this is 64 over 125. So now my I2 is 1 over 3 times 64 over 125. That means you will be getting 64 over 375. Okay, so from this first equation, my I4, I move down the 5 to the right side. So 1 over 5 of everything. The I2 replaced by the result. Okay, so now here, when you calculate, it will be, this is 1 over 5. Then the total for the brackets will be 4928 over 9375. We'll count the total of these two terms. So at last, you will be getting 4928 divided by 46875. So this is our I4 value. Okay, so I have completed the whole paper and we have come to the end of the video. Thank you for watching. If you enjoy watching my video, please subscribe to my channel and recommend it to everyone you know, right? And also stay tuned for more upcoming videos. Thank you. Bye.